These motors are a series motor. That means that your electrical circuit goes through the armature, which is the part that turns around, then through the field coils, and then back from the power station to the ground. And a series motor has no top speed. In other words, if we were to plug these motors into 600 volts right now, they would just go faster and faster and faster and eventually blow up. However, with a trolley car, there's a certain advantage to a series motor. It has its maximum torque, turning power, at 0 RPM, which is when you want it. When you're starting the train off, when you're starting the car off, that's when you need the most force. So how do you prevent these from blowing up? Well, it's very simple. You have a gear, which is a pinion rather, this is the small gear, which is directly connected to the ones that we saw on the truck. That's a permanent connection, and so therefore you have, unless something goes wrong, that motor will be kept from going at its maximum speed. In fact, it'll go faster and faster until it reaches what they call a balancing speed, which the friction of the bearings and the wind resistance of the car hold it to. That locomotive 100 might have gone 25 miles an hour. I'm only guessing. But it wasn't, speed wasn't what they were interested in. It was being able to pull 4 or 5 boxcars around. So here is the pinion which runs on the gear. Now we found that the gears and pinions are in excellent, like new condition. Those pinions operate, and the gear goes here, operate in this gear case. There's another half of it, which is next door. And this black stuff is a gear lubricant called Crater, or now it's called traction motor gear lubricant, which is basically the last thing in the refining process next to road tar. And they want something that will stick to these gears under the high pressure that they have.
How much do these motors weigh?
These motors weigh 2,450 pounds without the gear case on them, just that much, what you'll see around here, just a little over a ton. These are, for 40 horsepower, these are rather large. If they were to build a 40 horsepower motor today doing the same thing, it would be probably 1/4 the size of this. And the reason these are so large is because they hadn't figured out, they needed to keep them waterproof. The early motors were called a WP type, waterproof, because the oldest ones just ran everything exposed, and of course when it rained or slush and so forth, you had a real problem with, they didn't last very long. Then they put a case around them, and then they finally made these watertight. However, they hadn't figured out how to ventilate them, and these motors get warm, especially when you're pulling a lot of load, and they took care of the heat dissipation by having this massive heavy case here, and that soaked up the heat, and then it gradually went out into the atmosphere through the size of the case. So there's a lot of room inside of them, which you'll see in a minute when we look over at the other motors, and a lot of mass. And then gradually over the years they were able, number one, they could wrap the insulation much tighter, the wires much tighter, the insulation was better, they didn't need as much, and they could shrink them down in size.